Yeah.
Contact. Yeah, and you can do it. There's 400 hours. Yeah. So you can require.
I was gonna say, how old is he? 'Cause- oh yeah. Wow, that's awesome. My daughter's way too stubborn. She's like, Mom, I know everything because I'm a fairy, and you don't know what you're talking about. I'm like, okay, I give up. Go to school. Fine. All right, so we're getting a little bit ahead of our schedule, but I think it will be beneficial come 12.4, 12.5 when we talk about standard deviation and then normalizing curves and z-scores, because those are a little disconnected from mean, median, and mode and mid-range. These are going to be the 4 types of averages we're going to talk about, and we're going to talk about the pros and cons of each. If I give you the mid-range, that gives you an idea of kind of the distribution. If, you know, I say the mid-range is 10 points, means everyone had to fall within a certain range on a test. Typically, we like the mid-ranges to be smaller, saying, you know, ideally, you guys, you know, all do about the same level or have the potential to do at the same level. Depending on what you're measuring, your data points, there's 4 types of averages, and one average might make more sense than another average. So we're going to compute the 4 averages and then compare them. So they're also called measures of central tendency. Mean, median, mode, and mid-range are the kind of the 4 types there. Your book uses a sigma notation. Some of your calculators might have a sigma notation, and that means the sum of. So you can sum a bunch of numbers by looking at sigma most. I see a couple graphing calculators, and they would have sigma, and sigma is the sum. You see a capital pi, that's the multiplication. So if you take 1, 2, 3, 4, 5, 6, 7, 8, 9, and put that capital pi in front of it, it's going to multiply those all numbers together. If you put the capital sigma in front of it, it's going to add those numbers together. So your book says if I'm looking for the mean, I add all the numbers together, if there are n of them, and divide by n. We call that x bar. X bar is the mean. A short notation is to write the sum of all the x's divided by n. Doesn't really come up a lot because you're going to have a finite number of data points. Add those finite numbers together and divide by n. Sometimes we might have group data like we did last time, the classes, 1.01 to 1.5. You guys remember that example? We're going to go over one like that. If we're looking for the mean for group data, we have to find the midpoint of each class. Then I take the midpoint of the class times the frequency, and I add all those up and divide by n. Now this is getting a little bit more math notation, but if we put it in a chart, it's really easy to see, and we'll do some examples of that. Yeah. So this is saying, this is the midpoint of my first class. I multiply that by the frequency. That would say how many points that would represent. And then I'm going to divide that by the total number of n, which might be the sum of the frequencies. Here's a pretty basic application of this for median. So sometimes instead of saying the mean salary, if you look on salary.com, if you want to see how much a nurse makes in a certain area, they'll always give you the median salary. So that tells you, according to, in this example, we have the measure of average means that half of all government employees make less than $60,680 and half make more. So a lot of times people that publish salaries, they don't necessarily tell you the mean salary, they tell you the median salary, meaning half make above it and half make below it. Medium is a halfway point of the data set, arranged in order. When the data set is ordered, it's called a data array. The median will either be a specific value of the data set or fall between 2 values. Question?
Yeah, good question here. How close is the median and like the average?
Okay, they're all called averages. Mean, median, mode, and mid-range are measures of central tendency, and we all call that an average. There's different types of average. There's the mean, which is typically what is published as the average. Add up all the numbers, divide by how many I have. But the median is also a measurement of average. It's just the middle. The mode is a measurement of average, meaning most often. How many?
Okay.
Yeah, and
So
then we
let's
have
say
mid-range. So they're all averages.
The mean and the median technically should be pretty close together.
Probably so. Every time I give you guys an exam, I always give you guys the data points, and I give you the mean and the average. So sometimes the average could be 60, but the median could be 70. The average was 60, that means I had a lot of low scores. The median being 70 means half the class got above a 70. So those are two ways to give you the data, and so you kind of know, do you fall in the upper half or do you fall in the lower half? Do you fall above the average or below the average? But those are two different representations of average. Steps in calculating the median. So the first step is there's going to be two approaches. If you have odd amount of data points, you just find the middle data point, right? If I have 5 data points, the third data point in my list from smallest to largest is my median. If I have an even amount, then it's going to be, I'm going to add the two numbers together and divide by 2, the two middle numbers. And we'll see how that works. We need to select the middle value. If it's odd, the middle value falls exactly in the middle. If it's even, then the median is the mean of the two middle data values, right? So if I have 10 data points, right, the 5 and 6 are really kind of where the middle falls. So 5.5 is the median, but 5.5 is not in this list. So it's very possible that the median isn't in the list, the average of the two middle. If I have an odd number, then the median is going to be in the list, and it's going to be the one that shows up directly in the middle. There's 2 to the left of it and 2 to the right of it. Here, there's 5 to the left and 5 to the right. So that's how you, oh crap, I did it again. And we're going to go over some examples within this PowerPoint. Sorry, guys.
Why do you have multiple PowerPoints?
I have multiple PowerPoints, so then when I print them off, I don't print off all the examples. This is 12.3. Okay, so we'll calculate this example for mean that's in your kind of handout here. So we're looking at 12 inmates on death row, proven innocent and freed in the 5 years. After that, there were 6, 2, 1, 3, and 4. Find the mean number of death row inmates proven innocent for the 6 years from 2003 to 2008. So we have the numbers. Let's see if I can switch. Okay, so we have the numbers.
2004 and to 2005.
2003 is 12.
Right.
2004 is 6. 2005 is 2, 3, or 1, 3, and 4. My computer. Okay, so if I add up those 6 numbers and divide by 6, I get 4.7. So this saying on average in those 6 years, 4.7 inmates were proven innocent and freed. Some years only 1 was freed, and some years 12 was freed, but on average I had 4.7 freed. You don't have to necessarily write the sum of x over n. If you do, that's fine. These are semi-tricky to grade because I'm relying if you can punch these buttons in your calculator. So show your work, even though you think, oh, it's 12, 6, 2, 1, 3, 4 divided by 6, and you get something. If you have the wrong answer here, but the right work, I'm going to give you credit for it. I'm going to say, okay, they understand what's going on. Something went wrong in the calculator, so they understand how to punch it in the calculator. If you just give me the answer and it's wrong, it's pretty much no point to that. So we're going to look at an example of the classes, example 2. So the very first step here, we have to find the midpoint of each class. So if we draw a new table with the midpoint of each class and the frequency, this will kind of help us set up midpoint times the frequency equals the sum. Midpoint, these are the exact same midpoints that were on last 12.2, where we had to do the histogram, the frequency histogram. Now we're looking for the median, or sorry, the mean. What did this represent? The closing price of some stock, GM. So if I wanted to look at the mean closing price over these 74 days, so my frequency should add up to 74. I take the median of each class, multiply that by the frequency, and that would give me the sum of the frequencies. This is kind of how many times this happened in the 74 days. Now, it didn't close at 2.255, it closed within 2.01 and 2.50. So instead of adding up 47 different numbers and dividing by 47, you're only adding up 7 numbers. But it represents 47 days. The midpoint, just like we did last time, to calculate the midpoint, we find x1 plus x2 over 2. So in this case, it's 1.01 plus 1.50 over 2. Here, this would be 1.51 plus 2.0 over 2, and so forth. To find the midpoint, you take the first number plus the second number and divide by 2.
So we find all of the medians, and then we add it up, and then we divide by 74.
Not the medians, the midpoints.
Right.
Yeah, you find all the midpoints, you multiply that by the frequency, because the frequency is how many times that happened.
Okay.
Then that's going to be your sum of all the midpoints times the frequencies. This number divided by 74 is going to give you the mean.
Okay, so there's a lot of room for a mistake.
Exactly, with your calculator. Yeah, and in real life, you have Excel, and it does everything for you. But even then, if you've ever programmed or done anything in Excel, you get one little number wrong, it's going to throw it off. So you want to make sure it makes somewhat sense. And that's kind of part of it here. If I do the math, I get 2.69, which should make sense because most of them fall within this region here. If I would have got something over 5, I know I would have been definitely wrong. And something less than 1, I know I would have been wrong.
So you're dividing your total sum by the total frequency on your new chart.
Yes. And that would be, if I give you 74 data points, add all those 74 data points, divide by 74, it's going to give you a better approximation. But this is a lot quicker to do because you only have 6 numbers to add and divide by 74.
It doesn't feel quicker because we have to
Well,
figure out the midpoint.
Let me give you 75 numbers first and punch them in a calculator and see which goes faster.
Yeah, I assume I am punching in less numbers,
Yeah.
but it doesn't feel very fast.
And most of it's your organization skills. Can you write them? And here we're going to 3 decimals, which is just kind of, it's tedious. It's not hard, right?
Yeah, that's it.
It's just tedious, and that can be annoying.
What is the FX mean again?
This
Yeah.
is the frequency times the midpoint. That would be this number. The sigma in front of it means the summation of all those. And I've already added those together in my chart and got 198.87. So the mean closing price was $2.69. And that looks, decent. Median, we talked about odd amount of data points or even amount of data points, how to go about this. So this is an example of the 5 starting offensive linemen's weight for the Pittsburgh Steelers in the Super Bowl. So I have 5 different weights, and I want to find the median weight. So the first step is to write it from smallest to largest. So we have 315, 317, oops, 228.
285.
Sorry, 285. 340 and 345. And I'm looking for the middle one. 317. So these are 5 data points. So the middle one is going to be the third one. And you can always take the n is the number of data points. If you take n plus 1 over 2, that's going to give you the median location. So I wouldn't necessarily have to write all 6 of them. I only need to really write the first 3. That's a little dangerous because you might have missed 285 and wrote 315, 317, 340 and circled 340 thinking that's the median.
Well, I mean, you have to add the 2 and divide by 2. You're gonna miss 285.
Yeah, I'm saying if I was going to just list the first 3 and not look at all 6 of them, I started with 315, 317, 340, and then I saw that 285 was smaller than all those, so I put them out front. So that shifts my median. If I was just going to say I'm going to pick the third one I list, you got to be a little careful doing that. With 6 numbers, it's not hard to list all 6 out, but with 100, it might be. And a lot of times they'll give you the data in like a data array or a stem and leaf plot, and it's a lot easier to see what's going on. But here we get 317.
If there's, I went to the next one.
If there's an
Yeah,
even.
there's 6, you add them together, right?
So if
Middle
yes, if the middle 2, you find the mean of the middle 2. So you add those numbers and divide by 2. Okay. So here we have one of the authors of the book conducts a campus food drive at the end of the semester. The amount of food in pounds gathered over the last 8 semesters is shown below. Find the median weight. So we have 1, 2, 3, 4, 5, 6, 7, 8. It is already in decreasing to increasing. Is it in order? No,
The
it's
2
not.
middle ones are.
Oh yeah, so I could put that in order, or I'm really looking for the 8 plus 1 over 2 spot. So 9 over 2, which would be 4.5. So I'm looking at the 4th and 5th spot, but I need to put them in order, all right? And if I arrange the data points in order, like we do here, I'm looking for the 4th and 5th spot, which is these 2. Some, it's like with 8 data points, I want to find the value, which 4 data points are to the left of it and 4 data points are to the right of it. With an even number of data points, you're always going to have to find the median of those 2 numbers, of the middle 2 numbers. And the median is just like the midpoint, where you take the 2 numbers, you add them together, and divide by 2. So the median weight is 1,725.5 pounds. Any questions on that? A little faster than finding the mean.
I think I'm confused. I might be pushing something wrong, but I'm reading 1,660.
It's possible that this is not coming out. What are we doing?
I got it.
1700 plus 1751
The wrong numbers then,
Yeah. Divide by 2.
I just took 51 since that's the difference between those two, divided it by 2, and gave me 25.5, so I knew it was 7.5.
It was 34.51.
Yeah, I don't know where
You
my
got it right.
calculator.
I got it right.
Yeah.
I don't know how.
It's because, but this calculator, the order of operations, I had to put the numerator in parentheses. Plus 1751 in, didn't do that right. Clear. So if I would have done this, what my calculator actually did was 1700 plus 1751 divided by 2. 1751 divided by 2 plus that. So the way I needed to input it here would be 1700 plus 1751 in parentheses divided by 2, enter, and it gives me the right answer there. So yeah, what you did here is you said that this was a distance of 50, and if I divide that by 2, then I get 25.5, and if I add 25.5 to the lowest number, I get that. It's not going to always come out that nice, but I mean, if the distance was, 30, you can say, okay, I'm going to just add 15 to the smaller number, but it might not always
So if it was,
be that nice.
1730 and 1700, it wouldn't be 1750.
If it was 1730 and 1700, it would be 7. It would be. It would be. You're just looking for the midpoint. And to find the midpoint of any two numbers, you add them together and divide by 2. Yeah, and be careful with your calculator. That's one reason why I kind of want to see your work so I can see what you're doing. In algebra, we would do it with variables, so then I could see, oh, you understand because there's no numbers there to mess up. There's nothing to plug in your calculator. It's just placeholders. And then this is where we got to with the mode. And it's possible to have one mode, 2 modes, multiple modes. There's things as bimodal, which isn't really something we get into in this course. But it's possible to have no mode at all as well. So this is the data represents the duration in days of U.S. space shuttle voyages from 2002 to 2008. Find the mode. It's kind of hard to see because they're just listed. So if I write them into a frequency diagram or show kind of frequency table, I can see that the mode is 13 because there's 5 of them. So the frequency distribution just kind of gives it to us. Really easy to see that. So they just list, it was 10 days in 2000, what was it? 2, 10 days in 2003, 13 days in 2004, so forth. But if I draw the frequency, which one happens the most often? You can also use this diagram to find the mode. Sorry. You can use this diagram to find the mean by taking this number times this number, getting your multiplication, adding them, and dividing by 17. Yeah, 17 days or 17 years here. So 17 different spatial conditions. Or you can add the 17 numbers together and divide by 17. But there's only really 5 numbers. You're either adding 10, 11, 12, 13, or 15. What would be the mode in this list?
There is none.
There is none, right? Mode doesn't exist.
Is that zero, not zero?
There is no mode.
So no.
So it'd be, there is no mode. 0 wouldn't be the mode. There would just be no mode. Yeah, no mode.
No mode.
No mode.
Why is there, what, how is there no mode?
Because the mode is the most often. What shows up the most often? They all show up once,
Oh, okay.
so there would be no mode. If one of them showed up more than once, then it would be the mode.
Okay.
If all of them showed up twice, you know, you could say also there is no mode, or you could say all of them is the mode. It's going to be pretty straightforward. Either one thing will be the mode, two things will be the mode, or no things will be the mode. Like this example, number of wins in a 16-game season. Find the mode. 4 and 8. So it's possible to have more than one mode. So 4 shows up 3 times and 8 shows up 3 times. It's nice when they give you organized data. So survey of junior class, measuring, what is the mode? 1,425 people selected business, 471 selected education, 878 took liberal arts. Is there a mode? What category appears the most often? Business. So it's possible the data points aren't numbers, they can be categories, right? If I polled everyone here, how many people like cats, how many people like dogs, your response is either cat or dog. If I write cat, dog, cat, dog, cat, dog. That's basically what they're doing here, they just organize it. 1,425 people picked business.
So it'd be like, there'd be like 1,425.
Business, yes,
business
yes,
words.
yes,
I gotcha.
yeah. So here, it wouldn't make, I couldn't talk about a mean here because it doesn't make sense. I can't add business plus liberal arts and divide by any number here. So mode is sometimes the only measure of average you have when you have categorical data. So a lot of times people with numbers think mode's pointless. Who cares how many times it, you know, it happens. But in this example, that's the only way we can classify the data or talk about it is the mode in categorical data. Make sense? The last type of average we're going to talk about is the mid-range. And it's just a quick estimate of the middle of the data set. Now, things can be skewed. If I have a lot of people that do really well on the test, and I had someone that did 25 on the test, and I look at the mid-range, that just gives me a quick idea. It's really easy to calculate for the mid-range. But it might be off because the data might be skewed to the right or skewed to the left. Those things are called outliers, right? You've heard that term before, where maybe one student gets 100 on the test and the next grade from that is a 70. But if I looked at the mid-range, maybe someone got a 25, I'd say, oh, the mid-range is 75 points, but it really wouldn't be fair to represent that because there'd be a 20-point gap between the next lowest score. So we call that an outlier. So mid-range is really affected by low scores or high scores, where the mean and the median really isn't, because if I have, you know, one high score, it doesn't really matter if it was an 81 or 100, it's not going to affect the median. And the mean is adding up all the numbers and dividing by how many data points I have. So with large data sets, it's not affected as much. So let's look at this example. Find the mid-range, 12, 6, 2, 1, 3, and 4, the death row inmates. If I look at the mid-range here, we get 6.5. So if I kind of think of the middle point, if I add 6.5 to the middle point, I'm going to get my highest value. If I subtract 6.5 from my middle point, I'm going to get my lowest value. It's kind of what the mid-range is saying. Right? It's encompassing all the data points. This is kind of the length. If you think of this as the length of all the data points, this is half the length of all the data points. But it doesn't really tell you half the data is on one side or half the data is on the other. You don't know that. It's just a measurement of position. But you don't know where the data points fall within that. You just know, you would think if it was evenly distributed, half would be on the left and half would be on the right. But that's not always true. In this example, 6.5, only 2 of them fall on the right of 6.5, where all the other data points fall on the left. 4.5 is maybe a better representation, a better average representation in this problem. Because 1 and 12 are kind of outliers. So here's a list of golfers who finished the Masters tournament with a better score than Tiger Woods between 1997 and 2009. So it gives you the year, the number of golfers, find the median, the mean, median, mode, and mid-range for the data.
Can 0 be a mode? Is it
0
possible?
can be a mode,
Okay.
yes. It is possible for 0 to be a mode. It represents something. 0 people did better. Yeah. So it helps to write the numbers in order. It turns out there's only 13 different numbers here. Oh, do we have 13? Is it
I have a question about the mode.
13? Yeah, so we're looking at 13 years here. Mode is the most often. What shows up the most often? So 0 here is the mode. If I was just to throw out from 97 to 2009, most often 0 people did better than Tiger Woods. The mean, if I add up all those numbers and divide by 13, 5.54. So the mean is saying about 5.54 people did better than Tiger Woods at any given year, roughly. The median, the middle, would be 2. So half the times in those 13 years, 2 people or more did better, and half those 50 years, 2 people or more did less. Makes sense? It's cutting the data points in half. Mode, again, we talked about was 0. And then that shouldn't say mean. That should say mid-range. Oops. The mid-range would be the highest, lowest. It's 10.5. So that's kind of the length of from the middle, or not the middle. You can, I mean, here you kind of see the length of the whole. There's 21 points difference between the smallest and the largest. And then that divided by 2, that's the mid-range.
It just got confusing for me with mode because started thinking about the categories, and like in 2004 there were 24 people better.
Yeah, that's different though, because it's not saying the year. It's not connecting it to the year. It's just connecting it to the number of people. Like the death row inmates,
Yeah.
X amount for each year. Where versus what is the response? Is it a category or is it a number? How many people did better than Tiger Woods? That's a number. How many people picked business? That's a category. Or what'd you pick? You picked business. So the last 2 pages here just kind of sums up mean. So the strengths and means is it's unique. There's exactly one mean for any data set. It factors all values in the data set from the lowest to the highest. And it's easy to understand when you tell someone, a lot of times you even use the word average. The average on the test was 60%. Well, there's 4 measures of average, so it's not technically the average, it's the mean. But that's what generally people think of when they think of average. The weaknesses is it can be adversely affected by 1 or 2, usually high or low values. A lot of times I take out the zeros. If you didn't take the test, I don't put you in my calculation because I don't think it's fair to represent that. Can be time consuming to calculate for large data sets. Kind of saw that, right? So the weakness, the strength is it's unique, it can be calculated, and it means something because it used all the data points. The weakness in that, it's time consuming to calculate. The median is a nice measure of average because it divides the data set into neatly into two equal groups, and it's not affected by one or two extreme values. Like if someone scored 100 on the test, it's not going to affect the median. They would have scored an 80 or 100. If I put them in order, it's not going to affect it much. However, it can ignore effects of smaller or larger values that are important to consider. So I had, 4 or 5 people in here that got a 10 on the test, and I gave you the median. It might kind of give you an unrealistic expectation of where you fall if you think you fall above the median, but there's really 10 people that got zeros or something lower than that. So it can ignore those effects, but it's not affected by outliers. So depending on the data, if that's a strength or weakness. Mode, very easy to find. It describes the most typical case, and it can be used in categorical data, like candidate's preference, choice of major, etc. May not exist, so that's a weakness. May not even be unique. There might be 3 or 4 of them. Can be different from mean and median if the most typical case happens to be near the low or high end of the range. So doesn't give us too much data, and I don't even list the mode for the test. Mid-range, very easy to compute. Smallest number plus the largest number divided by 2 provides a simple look at average, right? It gives you just the easiest way to look at an average. However, it dramatically affects the extreme high or low values in the data set, but ignores all the numbers in between. You're only looking at 2 numbers here, the lowest number and the highest number. If all your data falls within that range and it's very close, it makes sense to use mid-range. But if you have outliers, it doesn't give you much information about the data set. Any questions? If we go to your homework from this section, it's very straightforward representation. You might have to do stuff with the midpoints and the frequencies. What did I assign in this section? 11 through 25, every other odd? Oh, sorry. 7 through 23, every other odd. What's the instructions here? So 7, 11, pretty straightforward. They're looking for the mean, the median, the mode, and the mid-range. And then describe maybe what would be the most meaningful average for the data set. 15, the same thing. Sorry, when I printed this out, the spaces are kind of weird, but on your book, it should be a lot better. There is like a space here where you can actually see. There's top 10 countries, cigarettes smoked per person in a year in the top 10 countries there. So you can look at that. Anytime when you have like the top 10 something, you would think that they're going to be relatively close. You're not going to have a lot of outliers. 19, again, mean, median, mode, mid-range. 23, mean, median, mode, mid-range. So here you're going to have to calculate the midpoint first, and then multiply that by the frequency, add that, all those numbers together, and divide by the number of frequencies. Again, your picture looks a little different. Your table's a little nicer. When I printed it out into OneNote, it makes it a little weird. 27, again, the same kind of approach. 29, I think that's, or you just go to 25. You don't even do 27. Again, you're just calculating mean, median, mode, mid-range for all these numbers. Not too difficult. All right. On Next time we'll look at standard deviation, and if you thought mean was difficult to calculate, standard deviation takes in account what the mean is. So you have to calculate the mean, then you have to look at every data point and say how far away from the mean is each data point. Get that number, square it, add all those numbers together, and then divide by the number of data points. So it is much more time consuming to calculate, but that's what we're going to calculate.
Is this one you said that people would come back and be confused?
No, I think measure of variation is going to be fine for standard deviation. What then we'll do from that is, so we're going to get variation. So we're kind of looking for what percent of the data points fall within a certain range. Standard deviation comes into that count. And we're going to talk about, there are, let's see if I can get the right PowerPoint here. Nice little picture. Oh, I did. Don't worry, we'll give everyone credit for today. You want the ones not here to suffer?
David, a good day to skip.
I know.
So yeah, so this is kind of we're going to talk about the variance and the standard deviation. It's time consuming, but I don't think it'll be too difficult. And then what I think students are it's going to take a little bit more brain power is when we jump from standard deviation to normalized distribution. And then we'll look at a table that gives us the area under the curve. So if I give you 2 amount of data points, and I say what percent of the data fall within that range, then you're going to have to go to that table, get information from that table, and then make, okay, there's 100 data points, 95% of them have to fall within this range because of the standard deviation. So mean, median, mode, mid-range, there's not a lot of applications other than that. Variance is where we get into kind of the variance, the standard deviation, and the normalized distribution, which is probably something you've not seen before. And everyone in here has probably seen mean, median, mode, mid-range.
I think I've seen it before.
You've taken this class before?
No.
No. Okay. I would say if you've taken this class, you've probably seen it, but I don't know where it would come up in high school curriculum. Mean, median, mode come up in middle school, mid-range, and all that stuff.
Well,
But
I
variance,
figured that.
well, yeah, that's everyone's.
So is that
be on that
where
different page.
is that where you like draw your graph and like it's like a bell?
Mm-hmm.
And then there's like a line going through here,
Mm-hmm.
and a line going through there, and then like you do something with them in between. Yeah, I see.
Yeah, so it's standard deviation. So we're going to be able to take every curve that we draw and normalize it. And when we normalize it, the center is 0. But every data point represents either a positive or negative number on that. Then we're going to take the table that's in our book, and it turns out, if we look at,
Yeah, you have to memorize that.
and you have to really memorize 3 numbers. This number, let's say from current slide, you memorize this number, and this number, and it's saying 68% of the 68% of the population of your sample falls within 1 standard deviation. So 1 standard deviation below and 1 standard deviation above. So you have to know the standard deviation. You have to be able to calculate that. But once you calculate it and you know the mean, you subtract the standard deviation, you add the standard deviation, and it tells you 68% of the data falls within this range. Then if you go 2 standard deviations, 2 below and 2 above, 95% of your data falls within 2 standard deviations. That's how they use the IQ tests and stuff. They say 100, an IQ of 100 is the mean, and then they look at the standard deviation, and if you look at 3 standard deviations, 99.7% of the population falls within 3 standard deviations. It's also how they do the growth chart, or there's interesting with weight and looking at different locations in the United States. What's the average weight for a certain state or a certain culture or a certain group of people? And then they look at the standard deviation of that and say 68% of the population falls within this range, and so forth. And so they can calculate various things from that. That's the empirical rule. So that's what we're going to get to. After we get there, we'll normalize it and get a z-value. And that's what we'll use a table for. The table looks like this. This is just a very small amount of the table, which has to do with the area under the curve, which has to do with percent of the population. But that's where we're getting to. And we'll have plenty of time to kind of look at that. Various different ways to do that representation. Any questions? I'll see you guys on Monday. Enjoy your weekend.